we don't have to play that out. All right, let's move on to the next question. Hydrogen reacts with nitrogen to form ammonia, NH3, according to the following reaction. Hydrogen reacts with nitrogen to form ammonia, according to the following. So here's our reaction with hydrogen gas and nitrogen gas making ammonia gas. And then it says the value of delta H is negative 92.38 kilojoules per mole. Delta S is negative 198.2 joules per mole times Kelvin. Calculate delta G. Okay, so let's write out the equation for delta G first. Delta G equals delta H minus T delta S. And there are two stipulations before we begin. First thing, temperature has to be in Kelvin units. Okay, so we've got to take our degree Celsius. I don't know what's writing over here. Okay, degree Celsius. We've got to convert that to Kelvin. So let's do that really quick. So we'll do 25 degrees Celsius plus 273.15 equals 298.15 Kelvin. So there's our new temperature. So we'll use that in a minute. The second stipulation is, if you notice, we have different units here. We have kilojoules and we have joules. So we have to make sure that delta H and delta S have same units. Okay, so I'm going to convert delta S to kilojoules. Okay, so let's do that really quick. We have negative 198.2 joules mole times Kelvin on the bottom, and we're just going to convert joules to kilojoules. So there's 1,000 joules in 1 kilojoule. Remember, when you put kilo in front of a unit, that prefix increases the size of the unit by 1,000. So that's why we said there's 1,000 joules in 1 kilojoule. So essentially we're just taking 198.2, dividing by 1,000, and we should get negative 0.1982 kilojoules per mole times Kelvin. So remember, cross out your units. Joules cancel out here, and we still have mole times Kelvin on bottom and kilojoules on top, which is why the units work out the way we've written them. Now we're good to plug everything in. You must do these first two steps, or at least make sure your temperature is in Kelvin and the units on delta S and delta H match before you solve for delta G. You have to. So if you need to write things like this down on your note card to remember that, I suggest you do. Okay, so now we will plug everything in. So delta G equals, let's plug in delta H, negative 92.38 kilojoules per mole. And then we do a minus, and I like to put these in brackets, so our temperature here is now 298.15 Kelvin. And then that is multiplied by our delta S, which is negative, I'm going to put that in parentheses as well, 0.1982 kilojoules per mole times Kelvin, and close the brackets. Okay, now we need a calculator. I'm going to solve for everything inside the brackets first. So we do 298.15 times negative 0.1982, and you should get a value, I'm going to write it in black, of negative 59.09. And what are the units? Well, Kelvin cancels, so it's kilojoules per mole. Okay, so that's when you solve for everything in the brackets, but we still have this delta H term here. I'm going to erase that, that one's confusing. So we've got to subtract these things now. So I'm gonna bring us up here. So now we have negative 92.38 kilojoules per mole minus negative 59.09 kilojoules per mole. And minus negative makes this into a positive. Okay, so I'm going to plug this into my calculator now. Negative 92.38 plus 59.09. And you should get negative 33.29 kilojoules per mole, which matches answer choice C. That is our delta G. Okay? All right, that is the end of that question.